The cabbage stem flea beetle is one of the most widespread harmful insects in the cultivation of oilseed rape, especially since the European ban on neonicotinoid seed treatment makes it more difficult to control the pest by insecticides. Crop protection products still available are also increasingly losing their effect.
The sensitivity of the cabbage stem flea beetle to insecticides has decreased significantly. Warmer autumn and winter temperatures favored by climate change can increase the survival rate and the activity of the beetles. That's why the development of varieties with improved resistance is a high priority for our breeding.
Some rapeseed plants are able to better protect themselves naturally against the cabbage stem flea beetle.
Our varieties with insect protect genetics have up to 30% lower susceptibility to the larvae of the cabbage stem flea beetle. And especially the larvae cause great damage to the oilseed rape plant and can lead to high yield losses.
But in other plant stages, the cabbage stem flea beetle also damages the plants.
The adult beetles arrive in fall, shortly after the emergence of the plants, and usually damage them already in the cotyledon stage.
Due to the 10-month cultivation cycle of winter oilseed rape, field trials can only be conducted once a year. And otherwise, breeding programs for insect resistance pose numerous challenges. That is why KWS experts work together in an interdisciplinary manner to optimally combine different aspects of pest control. These include seed treatments, crop cultivation measures, and new breeding methods such as genome editing, which are used in basic research.
The so-called CRISPR-Cas9 gene scissors cut the genome at a defined point, and parts of the genetic material can be lost or replaced. For example, a susceptibility factor for cabbage stem flea beetle can be deleted, or a gene from a wild oilseed relative can be inserted, and therefore its resistance can be increased.
A new variety with the desired resistance is created, much faster and more targeted than would be possible through conventional breeding.
The development of a variety usually takes 10 to 12 years. With the help of new breeding methods, this process could be much more precise and shortened by 20 to 30%.
Although breeding trials with genome editing have been possible so far, commercial cultivation of plants developed with these methods is strongly regulated and thus practically prohibited in most EU countries.
In the future, non-regulation under the GM regulation of plants that have been edited with gene scissors, only with species' own genetic material, could make it possible to take advantage of new breeding methods.